Welcome everybody to today's CKA lab. In this lab, we're going to answer some of the bunch of questions that they're asking us to answer based on the cluster they gave you. So we're just going to go through that one by one and answer those questions. Easy enough. If you do like my content, please like and subscribe. I would really appreciate that because it helps me with YouTube's algorithm. All right, let's get started. How many services exist? To do that, all we have to do is get svc. So we see that there are two services that exist. There's Kubernetes one and there's a foo one that I made earlier. So those are the only services that exist in the default namespace. Even though they didn't ask for that, I'll just show you that. If I do -a, you get other services that are running in a different namespace. In this case, these three services are running in kube-system namespace. All right, let's look at the next requirement. What type of services are they? All right, so let's go back to the default ones. The first one is foo. It is of type load balancer. What that means is in the backend, it created a Google Cloud load balancer that has an external IP address right here that you can get to even from internet. So that's one kind. The second one is a Kubernetes service. It's running on cluster IP type. That means it's kind of local to the cluster. It's not accessible from outside the cluster because it's an internal service for Kubernetes. All right, next question. What labels are assigned to these services? To do this, what we have to do is add this part to the command, show-labels. The first one, the one I created earlier, has the label of app equals foo because it was created from a deployment. And it was created by exposing a deployment. When you do that, it basically assigns labels to the service and the pod that with the name of the service and the deployment, which is foo. The second one has a bunch of labels that came automatically defaulted from the creation of the cluster, and you can see them right here. All right, next question. How come they don't have external IPs? All right, so well, the first one does, because I created this one by hand, and it was a type load balancer. That's why there's an external IP. For the other one, because it's not supposed to be reachable from outside, so it's a cluster IP type, which is why it doesn't have an external IP address. And we can confirm that even using an endpoint, kget. If we do kget endpoints, you see the endpoint for foo is here, which is the private endpoint, which is not the same as the external one. And for Kubernetes servers, this is the endpoint that is searchable at. And it's port 443 for Kubernetes because it's a secure service. Foo is the one I created. It's not secure. It's running on port 80. All right, let's see the next question. What port and target ports are assigned on Kubernetes service? All right, so if we do kget svc and Kubernetes, we'll only take a look at that one. And I don't know if we need that, but let's do it anyway. -oy means gives you more columns. So the port wise, 443 is the port. It doesn't show the target port. I think you can get that by doing a describe. Describe. K is alias to kubectl. K describes svc, Kubernetes. It gives you much more detail. The port is 443. That's the external facing port. External meaning not public IP, but out within the Kubernetes to get to it, the port is 443. Target port is also 443. That means whatever deployment or pod is behind this service is also exposed on port 43. So they match up. They don't have to match up, but they do in this particular case. All right, let's look at the next question. What endpoint is on kube-dns service? As you can see, the kube-dns is not visible by just simply running kget svc because it is running on a different namespace, which is kube-system. So what was the question again? The question was, what endpoint? Okay, so if we do kget endpoint, capital A for all namespaces, you see the kube-dns one. It has two different endpoints, looks like. Both are reachable on port 53. Those are the endpoints. All right, next question. Run a pod from using binlab's bastion and shell into it. All right. So this is going to be my image. All right. Let's save that here in the history. All right. So to run a pod, we run krun. Give it whatever name. Let's just say bastion. And then -- image for the image. I like this image because it has a bunch of tools that we can use for troubleshooting. It's created. If we do kget pod, container creating, and it's now running. Now we need to get a shell into that. For that, I'm not sharing my Chrome, so you can't see it. But basically, if you go to kubernetes.io website, just type in shell, and you'll get the exec command, which I will show you in just a second here. This is the command, and you will see in just a second. This is the example they give you, so we'll just use that. So k exec -stdin -tty, name the pod, in this case bastion. Now, I don't think this pod has bash, so we're going to have to use bourne shell, which is fine. We'll just do -- Let me show it to you that it will fail. It will say blah, 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 no such file or directory because that shell does not exist on that pod. But if we do bin sh, it should work. And now I'm inside the pod, right? And I will know that if I do a host name, it tells me the host name is bastion. So I'm inside the container right now. So the requirement was to get to the endpoint of the DNS service to prove that it's available. So to do that, we can use a command called nc, which is available on this particular container. And to do this, we need the endpoint, which was here. That's one of the IPs. So I should be able to do nc -v, v for verbose, z for ending the session, don't wait around. And that's the IP address followed by the port. And as you can see, from this particular container, bastion container, I can basically telnet into this IP address, which is the endpoint for the DNS service on port 53, and it is open, available, right? If I give it a different port, it will fail. Nothing means fail, right? So it didn't say open. So that's how you can prove that you can get to port 53 on the endpoint of the kube-dns service. Notice, being on different namespaces didn't matter. This particular container runs on the default namespace, and the pods and the service is running on different namespace, kube-system namespace, and yet by default there's no boundaries stopping it from this traffic to be successful. All right, I'm going to get out of the pod. Now I'm back onto my Mac. I believe that was the end of the lab. Let me make sure. On a pod, we did that. Should I prove that? Yeah, that was that. All right, I hope you found this video useful, and I will see you in the next video.